Hey guys, welcome back. I hope you enjoyed your nice weekend. Got a little time off. Today we're going to be talking in a little more depth about angle measurement. So what we talked about in the past was angles are measured in degrees. So when you have an angle, we'll just call it angle A. It's measured in degrees, and you're measuring how much you've rotated from one ray to the other. It's how much you've turned, and this is kind of your center. So how much you've rotated here. You're not measuring like the distance, it's just how much you've turned. If you've gone all the way around, you've gone 360 degrees. Let's just say we've gone 42 degrees here. So that's going to be your measurement. Now I want to introduce to you a little notation with this. So how we would write this, we would put a little m for measure. The measure of angle A is equal to 42. So when you have maybe a diagram or a figure with different measurements, these statements are going to help you. The measure of angle A is 42. So if we didn't have it over here and we just had this statement, we know, well, the measure of angle A is 42. We know this is 42 degrees. And this is going to be really useful in the future when it comes to finding missing angles and solving different problems. So we will be using this a lot. We want to be familiar with the notation. So on to our second slide, we're going to talk about angle addition. And we're specifically going to talk about this with adjacent angles. So angle addition is talking about if you have two angles and they are adjacent to each other, you can add them together to find out the total angle. And what I mean by that is, let's say we have this angle here and it looks like this, gets divided into two smaller angles, A, B, C, and angle D. If we were to say this right here in red, we'll call angle BAC. So BAC, that's our red angle, BAC. And then we'll go in blue, we have angle CAD. CAD. Now if we want to know the measure of angle BAD, we can simply add these two angles together. Notice how they are adjacent, they share a vertex and that side. So the measure of angle BAC plus the measure of angle CAD, if you add those two together, that's going to give you the whole angle, which would be the measure of angle BAD. Now let's say for this, let's say the measure of angle CAD was equal to 21 degrees. And the measure of angle BAC was equal to 47 degrees. If you want to find the measure of angle BAD, you simply just have to add them together. BAC is 21 plus BAC was 47 plus CAD is 21, and that's going to equal your total angle. That would equal the measure of angle BAD. And that's all this notation is, the measure of, in this case, the entire angle we have here. And we should end up with 68 as our measure for angle BAD. So if we go on to the next slide, we're going to do a couple examples of these, and then we'll talk about two special types of relationships. So on slide 3 now, our first example, we're trying to find the value of K. So the value of K is what we're looking for, and we have 61 degrees as this angle, 26 degrees as our angle here, and we know K is going to be the entire angle. So this whole angle is going to be represented by K. That's our variable here. So we want to find out K. So K is going to be equal to, we're just going to add these two angles together because together they equal the whole angle. So 61 plus 26. So K would be, we're going to go ahead and get 87 here. So the value of K would be 87. And keep in mind, K is not, this isn't angle K, this is just like a variable. So with the variable that represents the measurement is K. So K is 87. There's no markings, like there's no points, so we can't like call it angle anything right now. We'll just say K is 87, but we do know this whole angle is 87 degrees. Our second problem, we have this little diagram here, and we know this is 27 degrees. We know this angle is represented by the variable C. That's what we want to find. And we know this whole angle is 71 degrees. So by angle addition, we know that by adding these two angles together, we should equal 71. I'm going to make a little equation, because when these problems get a little harder, the equations will be really important. So we have C plus 27. You add the two smaller angles together, you're going to get the whole angle here. So we have C plus 27 equals 71. So C, you're going to subtract 27 from both sides. So when you subtract 27, you should end up with 44. So C equals 44 here. That's our value. This angle has a measurement of 44 degrees. That's how you can use angle addition. If you have two angles together, they're adjacent, they're going to make up the whole angle between them. All right, on to two more now new definitions for us. And these are special relationship pairs. So on to slide 4. The first thing we're going to talk about is complementary angles. So complementary angles. Go ahead and write it down here. Complementary angles. What's special about complementary angles is this is a pair of angles whose sum is 90 degrees. So let's say we have the measure of angle A, we don't know what that is, plus the measure of angle B. If when you add the two angles together, if they equal 90, we call them complementary. So angle A and angle B are complementary. So there's a few ways this can work. Maybe we are told that A and B are complementary, and we're given that the measure of angle A equals 33. So if the measure of angle A is 33, and we know that A and B are complementary if we're given that information, then we can just say, well, the measure of angle A, 33, plus the measure of angle B, they have to equal 90 together. That's what it means to be complementary. So then you could solve and find your measure of angle B. So the measure of angle B then would be 57. So B would be 57. That would make them complementary. You also could refer to them as like the complement of A would be 57 here because A is 33. That's just a little fancy way to say it. You also could have maybe you're given two angles and you're asked, are they complementary? So we could say, I'm going blue for this, are angle C and angle D complementary? And we'll say the measure of angle C equals 42 and the measure of angle D equals 38. And we want to tell if they are complementary or not. Well, the way you can check to see if they're complementary is simply by saying, well, 42 plus 38, what does that equal? If that equals 90, then they're complementary. So 42 plus 38, we should get 80, and that means they are not complementary because they do not add up to be 90. So there's a couple ways that you can see complementary angles or check for complementary angles. The last way you're going to see them is a very special case, and this is where it comes up a lot, is let's say we have a right angle. Now if you have a right angle, you know the angle is 90 degrees. And let's say this right angle is broken into two smaller parts. We'll call this part X, and we'll say this part has a measure of, we'll say 68 degrees. We're not told that these two angles are complementary, but we can conclude that they are because if you add them together, they make up the whole right angle, meaning they add up to 90. So simply because it's a right angle split into two smaller angles, we know they're going to be complementary. So then we could say if we want to find out x, well, you would say x plus 68 equals 90. So therefore, when you subtract 68 from both sides, you're going to get x is equal to 22. So that's how you can use complementary angles as well. If you have a right angle that's split into two angles, you know those two angles are complementary because they have to add up to the whole 90 degrees of the right angle. So that's one special relationship, complementary angles. Another one we'll talk about, our last one, is supplementary angles. So supplementary, very similar to complementary angles. The only difference is now we're going to have a sum of 180. So we have a sum of 180 degrees. So if we have the measure of angle A plus the measure of angle B equals 180, then angle A and angle B we would say are supplementary. And maybe you're given one of the measurements like we just saw, like you might know angle A is 150. If the measure of angle A is 150, then the measure of angle B, well, you'd have to do 180 minus your 150. Measure of angle B would be 30 then, if they are supplementary to each other. Or maybe you're given two angles and you want to test to see if they're supplementary. So maybe the measure of angle C equals 128 and the measure of angle D equals 52, and we want to check to see if they're supplementary. Well, you would just add them together, because if they're supplementary they should add up to 180. So 128 plus 52, when you add them together you get 130, 150, 180. So we have 180, they are supplementary. So these two angles would be supplementary as well. And a special case in where you're going to see supplementary angles come up a lot is when you're dealing with the straight angles. So when you're dealing with like a straight angle like this, you have a straight line, it makes the whole 180 degree angle, but let's just say there's a ray coming out. And we'll say this angle is x and this angle is 117 degrees. We're not told that these two angles are supplementary, but we know this whole angle here, this whole angle has to be 180 because it's a straight angle. So this whole angle is 180. Now if we break it into the two parts, they have to add up to be 180 because you're going to add those two angles together. So 117 plus x has to equal the whole angle, which is 180, meaning these two angles are supplementary. So to find x, you would subtract your 117 from both sides, minus 117, and you're going to find out that x, let's get it down here, is equal to 63. And there you go. There's your measurement of x here. So that's how you can work with supplementary and complementary angles. If you want to try a couple of examples, I'll go on to the next slide. If you think you understand, feel free to stop watching. So on to slide 5, we have little line A, line B. We're given this right angle, and then we're given that this is 27 degrees, this is x, and we're trying to find the value of x here. We want to find the missing angle. So because we see this little 90 degree marking, we know in total these two angles should add up to 90. So 27 plus x equals 90, and then just solve for x. So minus 27 minus 27. So x is going to be equal to, well, I get 63 here. So x would be 63 in this one. Now sometimes the equations you make are going to be a little harder. Maybe this isn't going to be x, maybe it'll be 3x plus 1. Maybe that expression will be in here. You're still going to make an equation similar. These two angles added up should equal 90 degrees in this case. Alright, our next one, then you'll be done for the day. We have this diagram. We have a straight line, and then there's a ray coming out of it. We're told this is y, and this is 42 degrees. We want to find the value of y. So 42 degrees, make that a degree symbol. When we add these together, they should equal 180 because they are supplementary. They should make, or this is a straight angle, so it should add up to 180. So y plus 42 equals 180. And then just solve for y, subtract 42, subtract 42. So y is going to be equal to 138. That would be our measurement for y here. And if you have any questions, please feel free to leave a comment or send me an email. Have a nice day, guys.